Hello friends, in previous lecture we have studied the ratio test and root test. We have taken examples from exercise 3.6. We will continue that exercise 3.6. So take the example. Show that if mod x less than 1, show that if mod x less than 1, then summation of n raised to 10,000 into x raised to n converges absolutely. So for series, summation of n equal to 1 to infinity n raised to 10,000 into x raised to n is equal to summation of an mod of n plus 1 upon n is equal to mod of n plus 1 raised to 10,000 into x raised to n plus 1 upon n raised to 10,000 into x raised to n, which is equal to n raised to 10,000 into 1 plus 1 upon n raised to 10,000 into x raised to n into x upon n raised to 10,000 into x raised to n. This x raised to n raised to 10,000 get cancelled and we will get this term. Therefore, limit n tends to infinity of mod of n plus 1 upon n equal to limit n tends to infinity of mod x upon 1 plus 1 upon n raised to 10,000 into x, which is nothing but 1 plus 0 raised to 10,000 into mod x, which is equal to mod x. By ratio test, if mod x less than 1, then by ratio test, summation of n raised to 10,000 into x raised to n converges absolutely. And if mod x greater than 1, then it diverges. Is it clear? Next example. If n is sequence of real numbers such that if n is sequence of real numbers, non-zero real numbers, such that limit n tends to infinity of mod n plus 1 upon n is equal to n less than 1, then should add limit n tends to infinity of n is 0. Solution. So by hypothesis, summation of n equal to 1 to infinity converges absolutely. As this is a sequence for which limit of n plus 1 upon n is l less than 1, therefore given series converges absolutely, and therefore summation of n is convergent series. Therefore, by necessary condition for convergent series, limit n tends to infinity of n must be 0. n must be 0. Is it clear? Next example, for what values of x does the series, example number 8, for what values of x does series 1 plus 2x plus 3x square plus 4x cube plus dot dot etc. converge. Solution, for given series 1 plus 2x plus 3x square plus dot dot etc. This is equal to summation of n into x raised to n minus 1, n is equal to 1 to infinity, equal to summation an mod of n plus 1 upon an is equal to mod of n plus 1 into x raised to n upon n into x raised to n minus 1, which is nothing but 1 plus 1 upon n into x upon n into x raised to n get cancelled. Therefore, limit n tends to infinity of mod of n plus 1 upon n is equal to limit n tends to infinity of 1 plus 1 upon n into x, which is equal to 1 plus 0 into mod x is equal to mod x. Therefore, by ratio test, summation of n converges absolutely if mod x less than 1 and diverges if mod x greater than 1. Is it clear? If x is 1 or minus 1. For x equal to 1 and minus 1, series is divergent. X is equal to 1 plus minus 1, series diverges. So if I put x is 1 here, then I will get 1 plus 2 plus 3 dot dot etc., which approaches to infinity. And if x is minus 1, then I will get 1 minus 2 plus 3 minus 4 and so on. That series is also divergent. That series also, because limit of nth term of that series is not approaches to 0. Next example, if summation of mod n less than infinity, if summation of mod n means it is convergent, is less than infinity, and for each n belongs to n, and for each n belongs to set of natural number, mod of bn plus 1 upon bn is less equal mod m plus 1 upon am, then summation of bn converges absolutely. Then summation of mod bn n equal to 1 to infinity is less than infinity. Solution, the given summation mod n less than infinity 1. Okay. For every n belongs to n, mod of bn plus 1 upon bn is less equal mod n plus 1 upon an implies mod of bn plus 1 upon n plus 1 is less equal mod Bn upon An for every n. In particular, mod Bn upon mod An, this must be less equal mod B1 upon A1 for all n. Okay. Which implies this, or this implies this, mod of Bn is less equal mod B1 upon A1 into mod An for every n. Is it right? So from 1, summation of mod B1 upon A1 into mod An is also less than infinity. Okay. So from 2, 3, and comparison test, summation of mod Bn n equal to 1 to infinity, this must be less than infinity. This must be less than infinity. Okay. Next example, test the convergence of series summation of n where n is equal to 3 minus e into 3 minus e raised to half and so on, 3 minus e raised to 1 by n. Okay. So for this series, for given series, mod of m plus 1 upon an will become 3 minus e raised to half and so on, 3 minus e raised to 1 by n, 3 minus e raised to 1 upon n plus 1 upon 3 minus e raised to half and so on, 3 minus e raised to 1 by n. These terms get cancelled, which is equal to 3 minus e raised to 1 upon n plus 1. Therefore, limit n tends to infinity of mod m plus 1 upon an is equal to limit of 3 minus e raised to 1 upon n plus 1 is nothing but 3 minus e raised to 0, which is 3 minus 1 is equal to 2 greater than 1. Therefore, by ratio test, summation mod an is equal to summation an is divergent, because here n's are positive. Discuss the convergence of following series. Convergence of following. So in that, summation of n equal to 1 to infinity, n equal to 2 to infinity, one upon log n raised to n. So here, limit n tends to infinity of, if I take this as summation of nth root of n, n's are positive, is equal to limit n tends to infinity of 1 upon log n, and it is nothing but 0 less than 1. Therefore, by root test, summation of 1 upon log n raised to n n equal to 2 to infinity is convergent. Second, summation of n equal to 1 to infinity one plus 1 upon n raised to 2n upon e raised to n, e raised to n. Okay. So is equal to summation of n, then limit n tends to infinity of n raised to 1 by n. I am not taking mod because these are positive numbers. Limit n tends to infinity of 1 plus 1 upon n raised to 2n upon e raised to n to the power 1 by n. By using law of indices, this will become limit n tends to infinity of 1 plus 1 upon n raised to 2 upon e, which is equal to 1 plus 0 square upon e raised to n raised to 1 by n is e, which is 1 by e less than 1, and therefore by root test, given series is convergent. Given series is convergent. Show that, next example, show that summation of x raised to n upon n raised to n converges for all x belongs to R. Converges for all x belongs to R. So here limit n tends to infinity of mod of n raised to 1 by n is equal to limit n tends to infinity of mod of x raised to n raised to n to the power 1 by n, which is equal to limit n tends to infinity of x upon n, which is 0 less than 1. Therefore by root test, summation of n is equal to summation of x raised to n upon n raised to n converges absolutely for any x belongs to R. For any x belongs to R. So with this example, our exercise 3.6 is over, and we'll stop this lecture here. In next lecture, we'll study very important result, which is nothing but Cauchy condensation test. With help of that, we can discuss the convergence of so many series. Thanks for listening lecture carefully. Bye bye.